Okay. What made last night's homework challenging? Fisher? Okay, yeah, the first one you had to read the words that went along with it because it said, number 1 said, refer to the homework helper, which is this problem up here. So you had to use this bar diagram. You also had to kind of understand what the bar diagram was showing. So it says, Paul has a fruit basket that includes 3 oranges, 4 apples, 3 bananas, and 2 grapefruits. Use the bar diagram to write and evaluate 2 numerical expressions to represent the total number of pieces of fruit in the basket. So that's telling us how much fruit he has in his basket. They already worked out that problem for you. But then this one says, refer to the homework helper. Suppose Paul went to the store and bought 4 peaches to add to his basket. So it's saying we have that bar diagram plus what? 4 peaches. Okay? Write 2 new numerical expressions to represent the total number of fruit in the basket. So I'm going to try and keep it all up here at the same time where we can see the bar diagram. Okay, so most people came up with this first one needed to be a 4. Okay, and several people said, but I have all the numbers because they didn't do what? Read carefully, add the 4. So there should be another 4 there. Okay, so that first one you should have filled in 4s into both blanks. Now, something we're going to focus more on today is how do we know what turns into multiplication? What do we always turn into multiplication? Kenley?
If there's more than one of that number.
Yeah, repeated addition. We turn repeated addition into multiplication. So if we have more than one of something, we turn it into a multiplication problem. So looking here, what do we have more than one of? Hutley? 3. I'm going to underline it. How many 3s do we have? We have 2 3s. What else do we have multiple of, Addie? 4s. We have 2 4s. So over here, I need 2 times 3 and 2 times 4. Jackson, will you pull that door shut? I can't reach it. Why do I have to put the 3 here and a 2 there? Why is there only one way that works here, Elia?
Because there's only 1 2 for the first one.
Yeah, if it was a 2, I'd have to put 2 times 1. And do we do 2 times 1 or anything times 1? No. Elise, why else?
Because in the second parentheses, there's already 1 4.
Yeah, the 4 is there. Do I have 4 of anything? No, I don't have 4 of anything, so that would have to be my 2 times 4 spot. Okay? So there are multiple ways that you can write these, but when we're filling in the blank, usually there's only one way that works. Okay, next page. Was number 2 a little bit easier or not? A lot easier? Okay, so for this one, just because I feel like you guys didn't have as much problems, I'm going to go ahead and just pull up the answers. Oops, hold on. Let it catch up. But should your answer look like that? Hopefully you got 73, but what should your work look like, Jackson? What should your work to find 73 look like? You have it.
20. 21 plus 18 plus 16 plus 18.
What does your work look like?
A triangle.
Upside down triangle, okay? Now, is it okay if you had these numbers, in a different order? Yes, it's okay if you had those numbers in a different order. Who has something that they think is still correct for this second one, but yours looks different? Aiden, what do you have?
21 plus the parentheses, 18 times 2, another parentheses, plus 16.
Okay. Does his work? Yeah, because he has 2 times 18 or 18 times 2 somewhere in there, and then he adds 21 and adds 16. Elise, what do you have?
I have 21 plus 16 plus parentheses, 2 times 18 parentheses.
Okay, does hers work?
Yes.
Yeah. Okay, if you did not get 73, I want you to try and rework your expression. If you can't figure out what you did wrong, I will help you in just a second, okay? Next one, was it an easy one or a harder one? Easier. So you think number 1 was the hardest?
Yeah.
Okay, there's that one. So 4 plus 5 plus 4 plus 6 plus 5. They just went straight in order. Is it okay if yours are in a different order? Yeah, you should have 1, 2, 3, 4, 5 numbers, 2 4s, 2 5s, and a 6. 2 4s, 2 5s, and a 6. 2 4s, 2 5s, and a 6. Okay, we're going to practice something over on the next page. What's lesson 2 called? Order of operations. Are we pretty good at order of operations already? Yeah. And actually I lied. We're not going to write on that page. I'm going to go ahead and pass out a notes page. We're going to do a few more examples. We're going to do a couple of order of operation examples too, and then you'll have the rest of the time to work on your homework because all we're doing today is review. Okay? Let me pass out your notes page. If you missed either of these expressions, if you didn't get, what was the answer at the top? 73? Yeah. 73 and 24. I want you to rework those right now. Okay? While I'm passing out this paper. I'm gonna hold on to your book. I'm gonna steal examples from it in just a sec. Go ahead and write your name at the top of that piece of paper I gave you. The rest of you guys can go ahead and close your book. You don't need them. Oops, I thought I paused that. I didn't. Sorry. Okay. Chapter 7, lesson 1 and 2 review. The examples at the top are a little bit different. I just felt like we needed a little more practice at this after all the questions I got yesterday. So it says, write each expression using multiplication and addition or multiplication only. So these are multiplication expressions. Who can tell me again what's the difference between an expression and an equation? Addie J. An expression does not have an equal sign. An equation does. How do we know what to turn into multiplication, Bryson? Yeah, repeated addition, if it's the same numbers added together. So in that first one, Mason, are there any numbers that are repeated? In this one right here. 3 plus 4 plus 5 plus 3 plus 3. None of those numbers are repeated?
Oh, no, yeah. 3.
The 3 is repeated how many times?
3 times.
So how can I write that in a shorter way?
Maybe like put like 3 plus 3 plus 3
That is 3 plus 3 plus 3. So we change repeated addition into multiplication. What multiplication problem would that be?
Oh, that would be
3 times 3. So that one we have, let's go ahead and change the 3's into 3 times 3. Can I do anything else to make it shorter? Nope. So Gabe, what do I have to do though so it's correct?
You drop your 4 and 5.
Yeah, I dropped down our plus 4 plus 5. So I got a little bit shorter. I really only got rid of one number there. Next one. Jackson, help me out. What do you want to do first?
16 times, 2 times 2.
Okay, you want to change the 2's into 2 times 2. And that's one problem that it doesn't get any shorter. 2 plus 2, 2 times 2, same answer, but that's what they're wanting us to do here. Okay, take over, Aiden. What else?
16 times 3.
Good job. 16 times 3. Lexi, is there anything else I need to add?
There's just 117.
Yeah, plus 17. Okay, and on these ones, you don't have to evaluate because that's what we're doing in lesson 2. You'll have plenty of practice evaluating these expressions. What about the next one? Clara, what can I do to that one? Yeah, 5 times 4. Could I also write 4 times 5? Yeah. What other addition sentence could 5 times 4 show? Lexi? Well, the fact 5 times 4. 5 fours. It could be 5 fours or 4 fives. Next one. Elise?
7 times 3.
Okay, 7 times 3 is where you want to start. What do I have to do with that 7 times 3? Put it in parentheses. Good job. Fisher, help me out. What else can I do?
8 times 2.
8 times 2. Would it be okay if I put 2 times 8?
Yes.
Okay. Anything else, Hutley?
Plus 9.
Plus 9. Good job. Okay, so that's like what we did last night, but I kind of made it a little bit harder. For this one, it says write each expression using addition only. And on this one, there could be multiple correct answers. Today, we're going to write 2 for each of them. On your homework, you only have to do 1. But like the one Lainey picks and the one Jackson picks might be different, and that's okay. They could both be correct. So 4 times 3 plus 5. Addie J, what could that tell me to do in all addition?
4 plus 4 plus 4 plus 5.
Okay, 4 plus 4 plus 4, because she did 4 3 times. So do you guys all agree that 4 plus 4 plus 4 could be written as 4 times 3? Okay, and then she added on the plus 5. I'm going to write or. What's one more? Lexi? Yeah, I could do 3 fours. 4 threes. 3 plus 3 plus 3 plus 3. So I have 3 4 times and then add on the 5. So both of those would be equivalent or have the same value if I evaluated them as the quantity 4 times 3 plus 5. Next one. Emma K. Help me out.
You could do 3 plus 3.
Okay, so 3 2 times would be 3 plus 3. Okay, keep going.
Plus 7.
Plus 7.
And then plus 4 plus 4 plus 4 plus 4 plus 4.
Ooh, that one got kind of tight there. 1, 2, 3, 4. 5 fours. I want you guys to try and write another one that's slightly different. And this one actually has more than 2, but I want you to try and come up with one more that would also be the same. Jackson, what'd you come up with?
2 plus 2 plus 2 plus 7 plus 5 plus 5 plus 5 plus 5.
See if I can squeeze that. Okay, so he did 3 2's. Can 3 times 2 be 3 2's?
Yes.
Okay, he dropped our 7, and then he did 4 5's. Does his work? Could he have left 2 3s and done 4 5s? Could he have done 5 4s and 3 2s? Yeah, so this one has lots of different combinations. I'm just trying to get you to see it both ways. Next one, 3 times 9. Who can do that in the shortest problem? The shortest problem. Addie B? 9 plus 9 plus 9. Let's keep that one simple. Who can just say what the other one would be? Kinley?
3 plus 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 3.
Yes. Nope, you did 10. 3 plus 3 plus 3 plus 3, 9 times. Okay, last one. I want you to try the last one in the shortest way possible. Try and keep it short. Think about, do you want to write something 7 times or do you want to write it 2 times? And again, both of them are correct. I'm just trying to help you learn how to keep it simple. Simple as possible. Carter, go ahead, help me out. Plus what? Okay. Who can just tell me what the other one would be? Elise, go ahead.
2 plus 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 3 plus, wait, no, plus 2 plus 2 plus 2.
Yeah, so it would be lots of 2s because it would be 7 2s and then 3 more 2s, so it's actually 10 2s. If you did 2 plus 2 plus 2 plus 2 plus 2 plus 2. Okay? What's 2 10 times? 20. What's 7 plus 3 plus 7 plus 3? 20. Okay, so it all should have the same value. Okay, so I felt like we just need a little bit more from last night. That's a little bit weird way of thinking about it, so I gave us a few more examples. Now we're going to go back to order of operations. I'm going to pull some examples straight from the book. We're going to try and fit 3 examples in this space, so try and write accordingly. So example 1, and again, I'm pulling these straight from the book. 12 times 4. They start off easy and then they get a little bit harder. 12 times 4 plus 10 times 8. I'm going to go ahead and make our PEMDAS over here on the side. My little checklist. Lainey, walk me through. What does the P stand for?
P stands for parentheses.
Do I have any? Nope, so I mark it off. I'm done with it. What does the E stand for, Lainey?
It stands for exponents.
Do we have any?
No.
Nope, we're already down to MD. Why do I write MD like that?
Because it's multiply and divide.
It's multiply and divide.
Twice.
What's the rest of that statement?
Left to right.
From left to right. Do we have any multiplication or division? Yes, so we're going to start on the left and find our first multiplication or division problem. Remember, we only do 1 step per line. I should have a nice, neat, upside down triangle when I'm done. Lexi, what's 12 times 4? 48. Okay. And remember, sometimes will I have to go out to the side and maybe do some algorithm? Yeah, if it's a high multiplication problem or a high division problem, we may need to go out to the side and do some scratch work. Am I done with all multiplication and division? No. Bryson, what am I going to underline next?
10 times 8.
Okay, what is 10 times 8? 80, and then we drop everything else straight down. Got all my multiplication and division done. I'm only down to 1 problem, but what is my rule for add and subtract? Augie? What's my rule for add and subtract? Lexi, help him out. From left to right. Okay, 48 plus 80. If you need to, go out to the side and do the math. But 8 plus 0 is 8. What's 8 plus 4? 12. So our answer is 128. And again, our work should look like a nice, neat, upside down triangle. Okay, they started off easy. We're going to get a little bit harder. Number 2, example 2. This one has lots of grouping symbols. 20 minus bracket 4 plus another bracket. 4. Open parenthesis. 10 divided by 2. And then they close the parenthesis, close the first bracket, close the second bracket.
We used to have some of these problems on like Excel, I'm pretty sure.
Yeah. Yeah, so anytime they open a grouping symbol, they have to close it. So like on this one, they just all close at the same time. What do we do if we have all of these grouping symbols, Lainey?
You start with the middle one.
The innermost one. So if you're looking and like these two go together, you go to the innermost one. Because we do have to do our parentheses first, but on this one, we have lots of sets. So we go all the way to the inside there. Bryson, what's 10 divided by 2? 5. So here's the fun part is we got to now copy all this. So do I need the regular parentheses anymore? Nope. So I'm going to just do that first set of brackets. I'm going to close both of those. I'm going to work backwards so I don't forget anything. Okay. Next, Ava, which set would you, because I'm not done with my P yet, my parentheses, because I still have grouping symbols. So which one would you do next? Which set? 5 plus 4, 4 plus 5, because that would be the next innermost set right there. That is 9. Do I need that set of brackets anymore? Nope. So I'm now down to one set of grouping symbols. Emily, what am I going to do now?
9 plus 4.
Good job. The 4 plus 9, because I still have those grouping symbols, which is 13. So really, I went all the way from my parentheses. Do I have exponents? Do I have multiplication or division? Nope. I'm down to addition and subtraction. What's 20 minus 13? 7. We have our nice, neat, upside-down triangle. Are these a lot easier than they were when we first started? Yeah. And today's actually supposed to be the first day you've ever seen these, and these are the problems they're giving you. That's why we spent some time before break learning them. Okay, I have one more to do together. I'm going to have to erase some of mine. I'm just going to erase it all real quick. Oh, it's not super long. I just didn't have enough room. Number 3 has... I'm going to try and draw these. You can do your best. If you can't draw that little symbol, just do a bracket, the box one. Plus, oh, don't have a 28 plus bracket, parentheses, 2 times 4 squared, close parentheses, divided by 8. Close brackets, close braces. That's an ugly one. Where should my eyes focus first, McKay? The innermost parentheses. So where are your eyes looking right now? 2 times 4 squared. So our eyes, since that's the innermost parentheses, that's where my eyes should go first. But inside of those parentheses, I have 2 operations. What 2 operations are in there, Lainey?
Parentheses and exponents.
Exponents and multiplication. How do I know which one I do first? Hutley?
Whatever one comes first on the...
Yeah, you follow the order of operations. So in the order of operations, Hutley, do we do exponents first or multiplication? Exponents. So I'm going to underline that 4 squared because that's actually what we're evaluating here. Is 4 squared 8?
No,
It's 16. Why, Fisher?
because 4 times 4 is 16.
Because it's 4 times itself 2 times. 4 times 4 is 16. So now the fun part. Copy everything down with just the 16 in there. Aiden, where are my eyes going?
2 times 16.
2 times 16. Do you know what 2 times 16 is?
32.
32. So I'm going to just fill in 32. Copy everything else. Can I get rid of the regular parentheses now?
Yes.
Yes. So I just need my brackets. Close the braces. So really, this whole problem was in grouping symbols. Jackson, where are my eyes going now?
32 divided by 8.
Good job. 32 divided by 8 is what?
4.
4. I can get rid of my brackets. I just have my fancy little braces now. Augie? 32. So yeah, this one, the whole problem was in grouping symbols. Did those braces really do anything on the outside? No, they did absolutely nothing. They were just trying to confuse you. So that goes all the way down to 32. Okay, we have about 17 minutes left. Your homework starts on the bottom. There, you will fill in the boxes just like we did at the top. And then it says the lesson 2 practice, evaluate each expression, 1 step per line. That means don't skip steps. Underline one thing, write your answer. From page 489, check your answers and rework if necessary. If you flip it to the back, what do you notice? You have the answers, okay? If you can't get to one of those answers, raise your hand and ask for help. Questions? Okay, go ahead and get your books open, or you can work on the table, but your homework's on page 489. It says it down there at the bottom of your paper. Okay, you'll see the order of operation problems, but you will work them on this piece of paper. Got it? Check.